All right, we are going to attempt to finish this chapter in one video. And if you did not watch my 5.1 ratios and ratio tables, that is definitely the most important section. And once you understand that, the rest of this chapter kind of splits up, in my opinion, into fairly easy concepts. Okay, so ratios and ratio tables we're done with. Now rates and unit rates. So when we have rates and unit rates are basically like the constant of proportionality when we from the first one, where we divide the top number divided by the bottom number. And what happens is we get a unit rate, and rates are often used in proportional relationships, where you have in a proportional relationship. So let's talk about identifying proportional relationships and graphs of proportional relationships. If you have a proportional relationship, your x and y, it starts at 0, 0, and it extends in some sort of direction, where x might be your time. And let's do time and distance. Those are always kind of easy to understand, right? So, and then this is my distance, and let's say this is 1 hour, 2 hours, 3 hours, 4 hours, and my distance is 50, 100, 150, right? So let's just say in 1 hour we go 50. So a proportional relationship, its graph starts at 0, 0. That's basically the main thing you need to know, because essentially what it's saying is that there is a unit rate, there is a constant of proportionality from the beginning. So I'm not going to get too deep into that, but after 1 mile we go 50, after 2 miles we go 100, after 3 miles we go 150. So what we have is let's just look at the end. Any one of these will work, but if we have 150 and 3 hours, and we divide that, we get 50, and this, let's say this is in miles, and this is in hours. So we have 50 miles per hour, right? And that's how it kind of works with a car when you're driving. How in 1 hour, if you're going 50 miles an hour constantly, for 1 full hour, you will go 50 miles. That's where we get the miles per hour idea. So identifying proportional relationships, that's more kind of how it graphs. But a proportional relationship is basically going to say that if I take 150 as a proportion over 3, that if I set it equal to 50 over 1, that these two things, when cross multiplied, will equal. 150 times 1 is 150, and obviously 50 times 3 is 150. So yes, these two things are proportional. So that's all of section 3, identifying proportional relationships. So I'm just going to take some random numbers and see if we get lucky. 5 over 3 equals 20 over 7. Obviously not. If I multiply 20 times 3, I get 60. If I multiply 5 times 7, I get 35. So these would not be proportional because they did not equal. Okay. So, yeah. And back to the ratio tables, it needs to have the same constant of proportionality also, where we're multiplying it, the same unit rate. So all this goes together. A constant of proportionality, a unit rate, a rate itself. Later next year you'll learn that this is also the slope of the line. So as you can see, there's a specific slope, whereas this would be a less steep slope. So all of those things are related to proportionality. All right, so we're moving on. Oh man, this eraser's weird. Okay, so we were gonna move on. I'm putting this all together because I was afraid that you guys would watch a video and realize that one video for unit rates and rates wouldn't be necessary. So unit rates, and then you may not watch more. So I'm putting it all together. If you need help with any specific section, more help with it, let me know. So again, rates and unit rates, you divide. So the difference between rates and unit rates is that 150 miles over, what did we say that was? Over 3 hours is a rate. Okay, you have two different units, miles and hours, and this is a rate. But when you divide these two, no matter what, whenever you divide two numbers, even if you divide 3/4 divided by 5/6, when you get the answer, let's see, so let's do that. 3/4 times 6/5, because I'm keep change flipping. That would be 2, 3, so I would end up with 9/10. So that would actually be 9/10 is the answer to that division problem. 9/10 per 1. So that's something we kind of need to think about. So even if you divide two numbers and you get 0.75 and the answer is 0.75, if you're dealing with rates where you have two different units, that's 0.75 miles per 1 hour. Okay, so everything over 1 is itself. So if you ever need a second number to go with it, slope or whatever you're, as we get, this is a little bit too deep for 7th grade, but just know that any number over 1 is itself. So the unit rate, 9/10 over 1, so this is the constant of proportionality. But if I need to know how, this would be 9/10 miles if we were using this per hour, per 1 hour. Okay, so anytime my whole point is anytime you divide one number by another number, if they have different units, you end up with a unit rate, 50. So if I just put 150 divided by 3 on my calculator, I get 50. But that is 50 miles per 1 hour. And why is this important? Because if I know, I'm going to delete this, rewind, and if I know that I go 50 miles in 1 hour, well then how many do I go in 10 hours? Well, that's 50 miles per 1 hour times, what did I say, 10 hours, right? So my hours will cancel. 50 times 10 is 500, and I'm left with 500 miles. Okay, so that's sort of how it works. All right. Anyway, I'm getting a little too into that. So unit rates, check. Identifying proportional relationships, check. That was just cross multiply and see if they equal. And they should. Then we have writing and solving proportions. Okay, so the only thing you need to know about writing and solving proportions is to keep your miles an hour in check, right? So make sure that if I say 150 miles in 3 hours, that I don't, and they say, is it proportional to, how far would, if you travel at 150 miles in 3 hours, how long would it take you to go 800 miles, right? Just make sure miles, 150 miles, 800 miles, make sure they're on the top, and that then my x would go here, then I'd cross multiply and get 150x is equal to 2400. I'm just cross multiplying. If you don't remember cross multiplying from last year, we need to have another conversation. I'm kind of assuming that you do. And then 2400 divided by 50. I don't have my calculator, but that would be the answer. I don't have it handy. So you get the idea, though. So that is literally all you need to do for writing and solving proportions, is just keeping them straight. And then scale models, scale drawings, is just that, using scale drawings. So let me tell you what I mean by that. So scale drawing, for instance, let's say that I'm making a model of a model of a skyscraper, and my scale depends on how big or small it is. Sorry, that was a skew mark. So for instance, I have this little tiny model, of my skyscraper, right? This is a skyscraper apparently. Of my skyscraper, and you know, you can't just build a full-blown one. So what I'm going to do is I'm going to make a scale model. Have you ever, I mean, you guys have seen those. A perfect example I think of is sometimes at the museums they have the little towns with the railroad tracks and the, you know, little rivers. They have that at the museum. They're really cool. It's really cool. It's like a little mini town, and there's a scale to it. So and then all we're doing is keeping track of, well, what's the model, the size of the model to the actual size. So model to actual size. So a skyscraper's huge, so I may want my model to be 1 to 100, right? So if this distance from bottom to top, so I'm setting up a proportion now where my scale is 1 to 100, so it's 100. So my actual is 100 times bigger than my little model, and let's say my little model is 12 feet tall. All right, so it's kind of a big model actually. That's aggressive, but let's just pretend we did it. We made a 12-foot tall. I probably wanted to do 12 inches. Yeah, let's do 12 inches. Let's not. 12 feet's taller than a basketball goal, so that would not be a model. That'd be a structure almost. Okay, so we have 12-inch tall. So if that's true, then we would put, this is the model size is 12, so 12 goes here, and I would want to know how tall is my actual, how tall is the actual skyscraper if this 12 inches is true. How big is the door if this door right here is 1 inch? Like, all these things are done. You just put the model here, and then you cross multiply. I get x is equal to 1200. So, you know, if this were actually a building, then that building would be that long. And then if I did it model to actual is equal to 1 over 100, because it's 1 for model, actual is 100 times more. And I tell you that my building was 15,000 feet tall. How much would that be? Then I would need this to be x. I'd multiply. I would get 15,000 divided by this times this and this times this would be 100x. Divide both sides by 100. 100. That goes away. And if you guys haven't figured this out yet, you can cancel your zeros. So this 0 and this 0 cancel out. It kind of makes it easier because then it's 150. You don't have to do the math or use your calculator. That's what I've always done. So yeah, so that would be 150. At 1 to 100, I would need 100. If it was 15,000 feet, that'd be huge. Sometimes I just make up stuff that doesn't make any sense. Sorry about that, but you get the idea. So that's your scale drawings. But the whole point is, anytime you have a proportion, you have to make sure that model to actual, miles to hours, boys to girls, whatever you're comparing, make sure you keep them in line. So this was my model size, this was my model size, this was my actual, this was my actual. They have to be lined up. Keep them on the same line. All right, guys, hopefully that helps. If you, like I said, if you need help with anything specifically in this chapter, I just feel like 5.1 really lays it on you. It's super difficult. It's a little difficult. But once you figure it out, get all that done, the rest of the chapter sort of just makes sense, if the first section makes sense. So I'm hoping this video will help. Take care.